All right, we're back. We've been looking at string arrays because we're trying to transition into object arrays. In this one, we're going to be working with one of our custom objects. What I have is our mouse class that we've done before. Just a quick reminder about how mouse works. We have a mouse with some instance variables, an age, a weight, a growth rate, and then a growth rate change. And we're going to try to create these mouse objects with either constructor. I got a default, which is the typical lab mouse on day one. And then we have a constructor that takes in a value for each of those instance variables so that we can kind of customize how our mouse starts. Maybe we've bought it from a different lab before we decide to grow it. And this method grow simulates 1 day of growth. We, of course, we're playing around with pointers, and so the equals method exists to kind of demonstrate that. And we have our toString. I'm going to flip over to my driver, and I'm going to wipe it clean. Let's just delete everything that's in our main method. Let's make a mouse object real fast to kind of reiterate how this works. So I'm going to create a mouse called Mickey, and it's a new mouse. Here I'm using the noargs constructor, and so we're going to create the mouse with these values. I can see that by just printing off Mickey real fast. Okay, and so there is our mouse, initially 300 days old, 0.68 ounces, etc., etc. All right, let's throw in a different mouse. Remy is going to be a new mouse, and let's use our other constructor to kind of give some separation between these. Some lovely values here. 17 days old, weighs 18 ounces. It's going to grow at, what is this, 19 ounces per day. And then we're going to adjust that by 20%, or is that like 200% or something? Who cares? We're going to then print off Remy to see what Remy's stats look like. And there's Remy. It is 20% per day. Interesting. Okay. What we're trying to demonstrate is a object array. I have a mouse object. I've got two mouse objects actually. I got Mickey and Remy, right? And these are supposed to be lab rats, lab mice, if you will, that I can tell to grow. Right? I can come in here and I can take Mickey and I can tell him to grow, and we can see the change to Mickey by printing that off. I can take Remy and tell Remy to grow, and we can see that change by then printing Remy off. The thing is, if I'm going to have a whole lab of mice, I really want all of them to grow. I really want to simulate 1 day of growth on all of them. And that's really where this idea of an array is going to come in, because it's going to allow me to take my mouse objects and group them together. What do I mean? Let's backtrack here. I don't need these SOPs. I don't need this grow, but I am going to keep the mouse objects. I'm going to let these guys stick around. What I'm going to create now is a mouse array. Right? Mouse is our data type that we came up with, and you'll see the syntax is very similar to how we create an integer array, a string array. I'm going to create my mouse array, and I'm going to call it lab. And it's going to be a new mouse array. Now, here's the thing. Just like with any array, I'm going to need a length. I got two mouse objects currently, so why don't we just start with 2. Okay, what's awesome about this is mouse is a data type that we have effectively created ourselves, right? It is an object, and we can then, once we have that data type, not only create mouse objects, but I can create an object array that can hold mouse objects. Just with our normal syntax, I can take that array and then edit the elements, right? The element at index 0. Well, this is a mouse array, so the individual elements can be mouse objects. I'm going to set lab at 0 to be Mickey. I'm going to set lab at 1 to be Remy. What I've done is basically taken these mouse objects and stored them in my mouse array. They're grouped together, right? They're now associated because they're both are in this lab. The reason I'd want to do this is because I want all the mouse objects to grow, right? I want to simulate 1 day of growth for the entire lab. Okay, so what I'm going to do is loop through lab. We'll demonstrate the idea with the for loop, and then we'll go back and demonstrate it with a for each loop. But the array I'm ultimately looping through is going to be lab. So we'll do lab.length. Okay. What I want to do is tell each of these mouse objects to grow. So I'm going to loop through the array. And with each iteration, I'm going to get the current mouse object, that is lab at I. Right? Lab is a mouse array. Lab at I is a single mouse object. So what I've highlighted, it is a mouse. Don't let any of the text confuse you. I have a mouse. From there, I can tell that mouse to call some methods. The method I care the most about is grow. Okay. So in order to actually see this growth, I would maybe want to see the before state. I would maybe want to see the after state. So a couple of ways you could do that. You could do it maybe here, print off before, grow it, then print off afterwards. And so you would see the mouse objects kind of as they are growing. But I tell you what, probably the easiest thing to do, I could loop through and print off the toString. Yeah, let's do that. That's really what I should do. I'm going to use a for loop. I'm going to loop through our lab. And what I want to do is see what the initial state of these mouse objects looks like. We'll then tell them to grow, and then we'll see the state after the fact. Okay, so with each iteration, I'm going to print off the current element. Now keep in mind that whenever we print off effectively a object, what we're doing is calling the toString. I'm effectively saying lab at I dot toString. Now lab is a mouse array. Lab at I is a single mouse. So what I'm calling is the toString of mouse, this thing, which will show me all of this data. Okay, why don't we do that? We'll see what the before state is. We'll then tell them to grow. Right, here is effectively Mickey. Here is effectively Remy. And then I'm going to tell them to grow. And I want to print them off again. Okay, here is Mickey. Here is Remy. Before we tell them to grow, maybe we can put in some type of separator there. We then see Mickey 1 day later. He is now 301 days old. We see Remy 1 day later, and we see the changes made to them. Okay, what is so nice about this is that I effectively kind of dynamically told each of these things to grow without having to specifically refer to Mickey or specifically refer to Remy. Same thing in terms of kind of displaying the contents. I'm going to get rid of these braces so we can reduce the amount of brace clutter we got going on here. So this is cool. We can create an object array for the custom objects that we make. We wrote the mouse object, their mouse class. Why don't we add some more mouse objects to this? Okay, here I've created the mouse objects in advance, stored them into variables, and then basically stored the variables into the array from there. That being said, I want you to recall that there's effectively two things happening here with this construction statement. The left-hand side, we're declaring a variable. The right-hand side, we actually have object construction. One thing you can do is create an object effectively without the variable. I'm going to, let's make our lab a little bit bigger. Let's go up to 3 mouse objects. I'm now going to take lab at 2, and instead of setting it to something like Mickey or Remy, a mouse object that already exists, I'm going to create the mouse object right here. Right? Object construction. I'm saying lab at 2 is going to be equal to a new mouse. Really, and the reason why I keep kind of winking at the camera, I'm saying lab at 2 is going to point to a new mouse object. More on that in just a second. Okay, let's see this new mouse come in. Maybe I will print off that separator. I'm just going to do that there so I can tell when we are done, basically displaying our mice and tell them to grow and then seeing the difference. So here initially we see 3 mouse objects. Now my first mouse and my last mouse both went through the no arcs constructor, which is why they have the same values. And likewise, that's why they have kind of the same growth. But what I'd like you to recognize is this is a third mouse. It has nothing to do with Mickey, it has nothing to do with Remy. In fact, we'll plug in some different values here. Run our program again. And you see that we have a mouse that after 1 day is going to get pretty big. Okay, sweet. So the benefit of this is that I can take multiple objects and kind of group them together in the same way that we could with integers or doubles. Yeah, so about the only thing I would kind of add to this is that we could simulate multiple days of growth, right? This loop is going through telling each of the mice to grow, right? What if I wanted to do multiple days? Well, I can effectively put this, which is 1 day, right? What I have highlighted is 1 day of growth for our lab. Okay, what if I want to do multiple days? Let's put that in a loop. Let's say I wanted to do 10 days of growth. Of note here, right, it's mad at me because I already exist in this context. Probably should have renamed this whenever I was making the loop, but I'm going to switch those to K. Okay, so this is going to simulate 10 days of growth in the lab. I'm going to tell that to run. We're going to see our initial state, and then we see 10 days later our values. One of the things I mentioned is that we could use a for each loop. And the important thing to keep in mind is what you're looping through. In this case, lab, which is a mouse array. And then what the data type of the individual elements are, which are just going to be mouse objects. So if I was going to maybe, let's just say print, right? Let's just comment this bad boy out and redo a for each loop that will allow us to print the elements. I'm going to say for. What I'm looping through is lab. Each individual element in that mouse array is a mouse. So I'll say for each mouse, let's call it M, so people don't get confused. IntelliJ's recommending a lowercase m. That's going to be confusing because, right, this is a data type and this is a variable. I'm just going to say M in lab. How about we call it a rat? For each mouse, which I will refer to as rat, in lab. Okay, this is effectively going to be the exact same thing. But instead of having this index and having to pull the element out, that is being done for us with each iteration. So if I want to print off the current mouse, the way I refer to the current mouse is just simply rat. Right? That's taking place of lab at I. Likewise, we could replace, this loop, which would be kind of a little bit more ideal, so I can get my I variable back. But that's the gist of it all. Here is one of the things that is interesting. There's nothing too tricky about this, but all an array is a collection of variables. This lab is a collection of 3 mouse variables. So when I tell lab at 0 is equal to Mickey, what I'm really saying is that lab at 0 is pointing to Mickey. Let me show you maybe with a visual. Okay, here I have a construction statement where we're creating a string array called dog breeds, and I'm setting it equal to a new string array with a length of 4. Visually, it looks something like this. I have the variable that is going to point to the string array. Recall that when an array is initially constructed, it will be filled with the default value of the corresponding data type. In this case, we're talking about a string array, and those are strings. Strings are objects, and the default value for object is null. So in this case, we're going to be filled with null values, right? If I just do this, there's going to be 4 null values. That visually looks like this. Now, and this is the part that I almost am scared to show you, but it's really what is happening. Technically speaking, an object array does not store objects. Instead, these are variables. These are just pointers. Visually, it's more so like this. Dog breeds is pointing at a string array. That string array is a collection of 4 string variables. Initially, all those things are null. What that means is those 4 variables are pointing to null. If we come in here with our syntax where we take the array name, in this case it's called dog breeds, we pick an index using square bracket notation, and we tell it to point at some string, right? We're saying dog breeds at 2 is going to be beagle. What I'm doing is I'm going to take this variable, tell it to stop pointing at null, and tell it to point to beagle instead. Right? Initially, this is what my array looks like. I come in, I say dog breeds at 2. That is this variable right here. I'm going to point to beagle. Right? Notice it's no longer pointing at null. It was pointing at null, but as soon as I change the pointer, it is referencing beagle. It is pointing at beagle. Okay? I don't want you to get too confused by this. This is just, a string array is just a collection of variables. There are 4 string variables that I've put together, but instead of the variable name being some user-defined symbol, right, like Mickey or Remy, it is just one of the spots in our array. The same thing is going on here. What do I mean? I have this variable, Mickey, which is pointing at this mouse. I am then telling this variable to point to the same thing Mickey is pointing at. Okay, I'm not going to dive too deep into this, but what this means is I, in a lot of ways, have 2 variables, right? Mickey and lab 0, both referencing the same object. So if you were to come in here and take Mickey and tell it to grow, or you were to take lab 0 and tell it to grow, those are effectively the exact same object because those 2 variables are pointing at the same object. Where this gets interesting is, right, we're breaking this apart and we're seeing that we can kind of create an object anonymously, right? It looks like there's no variable pointing at this. I'm making it on the spot. But when you recognize that this basically is a variable, well, there is a variable. There is a reference. The way that I get to this object is by going through this variable, lab2. And that's what I really want to kind of point out. A lot of this stuff starts to make sense and it starts to jive. And maybe I should show this change. Right? Why don't we comment everything out? I'm going to do all of this. Let's take a look at Mickey. Okay, let's take a look at lab 0. Those are going to be the exact same. Right? What I'm going to do is take Mickey and tell Mickey to grow. We're going to print off Mickey and see that change. But I'm also going to print off lab 0 and see that change. Again, this is basically a variable pointing at the same thing that Mickey is pointing at. Conversely, if I came in here and said lab0.grow, I'm going to end up with the exact same thing. Okay, so this has been kind of our intro to object arrays. Right? It's just important to note that we're dealing a lot with pointers in the grand scheme of things, but data types matter. As we saw, we can loop through our array, get the individual elements, and based on their data type, it dictates what methods we can call. In this case, they're a mouse, and so we can tell that mouse to grow. I'll see you in the next one.